right, there we go. We are live. Hello, everyone, and welcome back. We are in the final 30 minutes or so of the Golem 1.0 launch hackathon. And by now, competitors have worked for 32 hours trying to build a Twitter clone using the primitives that Golem exposes and in one of the programming languages supported by Golem. And in one case, one of the programming languages not supported by Golem. We'll get back to that. Anyway, so we have 5 official submissions for the competition. And of course, there can only be 3 winners. So now what we're going to do is we are going to allow each of these contestants who've put a lot of effort into their solution to present their solution to the world and talk about architecture and show us some code, give us a demo, and then talk about any extra features they added or features they weren't able to implement in time, limitations that their solution has, and so forth. So let me just make sure that we have all of our competitors in the chat or in the meeting. Looks like we're missing a few. We have Abdullah here with us. Welcome, Abdullah. And then Simon Wick. Welcome, Simon. And then we have Danielle. Welcome, Danielle. And then we do not have Abdul. So we're missing Abdul. And then finally, we're actually missing, oh no, there he is. There's Sita. Okay. Welcome, Sita. So the only person we're missing, maybe Christina, you could try to get a hold of Abdul. Glenn, is Glenn does Glenn have a solution? Okay, I missed Glenn's. Oh, he just posted it very early. Well, congratulations, Glenn, on beating the deadline to post your URL. Let me go ahead and invite you. Okay. All right. So, Christina, if you can go ahead and try to find Abdul, because we did take a look at his solution. 1 second. All right, so we are going to go ahead and get started with, I think we're going to do Abdullah's solution first. So Abdullah, would you go ahead and share your screen for folks and unmute yourself, turn on your video camera if that's something you're comfortable doing, and go ahead and present your official solution to the Golem 1.0 launch hackathon. We're all excited to see what sort of Twitter clone you've been able to build over the span of 32 hours.
All right, so okay, so a little bit about the architecture that I had in mind. I didn't have like the chance to implement like all of it. First of all, the main requirement was to be able to scale the users, like not the followers and not anything, just like the users pillar. So the first thing that I thought about is like, you know what, we can make like each user has its own worker, and we can maintain the state of each user inside this user's worker. So no need for a database or anything, just like maintain the state in the user itself. And and we will have some sort of a user manager worker. And this user manager is supposed to maintain like the list of all active users. And it's responsible also for creating users. So basically, like the sign in, sign up process will start with the user manager. You'll call the user manager to sign in. It will search to see if the user is already there. And then it will bring back like the user ID that you can initialize your like session with and do like all of the subsequent calls. And I think one of the things that I didn't know how to do is like, so this user manager will be reached by like all users. And since we need to scale based on users, it's gonna be like a bottleneck. But I think the solution here is to like have like multiple workers for this user manager and shard the state somehow. So and try to like, yeah, try to make this happen, but I didn't really know how to do it in Golem. So, but yeah, but this is like the idea. And for the timeline, I thought first about like a centralized timeline, but yeah, it's gonna be a bottleneck as well. And composing like the timeline for each user is gonna be hard. So I eventually was going to implement that the timeline will be also persisted in each user's worker. So each user will have his own timeline. And basically what will happen is when the user tweets something, the list of tweets will be added to the list of tweets of the user itself, and then the timeline of each of his followers will be updated with the tweet. So this way, and since we don't care much about like scaling based on followers, so this process will not be like that cumbersome or that complicated. So yeah, this is like an overall view of the architecture that I had in mind. Um, what I managed to to implement though is like a tiny piece. So I was trying to give
32 hours is not a lot of time, is it?
yeah. So what I was trying to do is like to make like one scenario working end to end in Golem. So what I did is like I created two components. Let me show you like on Golem. So I created two components, one for the user and one for the user manager. And I've created some APIs to invoke like the functions of both components. And basically the functionalities that is working right now is like you can call the user manager to create a user, and then you'll get back the ID of that user, and you can use that ID to invoke each this user's worker to get the profile data and update the profile data. So those are like the four APIs that I managed to get working end to end. I think the challenging part was like to call to make worker to worker communication with uh, by the aid of the gateway. So I'm not doing like actual Golem worker to worker communication. I did it like through, so each function is exposed to an API. So I'm calling basically from the user manager's API, from the user manager to the user's API. So it's not like internal communication. So
You're
this
not
way,
the only one who did that. So, worker to worker communication is one of the things that we intend to polish post 1.0. And, in different languages, it could be different levels of pain. So, you're not the only one to go through the front end Rust API in order to do worker to worker.
okay. So yeah, let me show you like a quick demo of that. So first of all, let me bring Postman. So the API, the first API is like slash manage slash user with a post call, and this is basically will create a new user and bring back the ID. Let me clear that. Okay, just bring this out of the way. Clear. Okay. So let's say this is like the request body. So just a name and an email. And when I do a post call, so it brings back an ID. And if we go here as well, we go to the component itself. I have some logs. This like UI is really cool. It was like, yeah. Um, so let me go to the worker. It helped me a lot. So I have to say. So yeah, so as you can see here, it's like this is a post request to create the user, and the user has been created successfully. And what I have here is like there is a mapping between the user ID and the worker itself. So basically, if we took like the ID that's being returned, or let's search for other, so the other workers. And if we search here, we should find a worker. So this means that this user was created by the proper ID, and we have like an actual user worker. So, and the second stage is, and by the way, if we like do another call, it should bring back the same ID. So basically it should return a 449 or something, but yeah, but I'm just returning the same ID. Okay, and let's get the profile data first. So let's see what was it was Ahmed. Okay. So let's see, let's set the ID in the params here. Okay, let's clear the response. Okay, and if we do that, okay, we will get the data. Okay, let's update the name. So let's see, this is a put. Let's go with uh, uh, anything, John. Okay, let's keep the email as it is, or like we can change it, it doesn't matter, but like there should be a validation on the email because I'm doing a map based on the email, and the email should be unique. And so, but yeah, but now it's updating everything. So, so yeah, let's just update the name for now. Okay. So when you update, it's gonna return the updated profile info. And if we get it, just like to make sure it's updated. Yeah, it has the updated name. So basically, that's what I managed to implement with Golem. So I was supposed to do like the rest of the stuff, but yeah. Okay.
Oh, no worries. You did implement something and it is working. So congratulations on that.
Okay.
And before we move on to the next demo, just what's your favorite feature or favorite aspect of developing on Golem? It was your first time. What really stood out as being, oh, this is really nice?
Um, I think the idea of having like those workers that do not fail, like it's guaranteed that if you like implement it right, it's not gonna fail. Like this idea is like um it's really powerful when it comes to like system design. When you design something based on that idea, it's just much simpler. It's like a lot of complication out of the way. So so yeah, I think that's the best
That's
thing.
great to hear. And if you were to have our Golem contributor team improve one aspect of your experience building on Golem, what would that be?
Support for other languages, because I did that in Rust, and it's my first time to do anything in Rust actually.
You're a
So
brave man. Congratulations on that. Welcome to Rust, by the way.
so yeah, if like especially the documentation part, so it's
Yeah.
gonna make like yeah, development a lot easier.
Okay, I appreciate that. That's fantastic feedback. All right,
And
thank you so much.
special thanks to the team, like the team were very helpful. So yeah,
Glad to hear that. All right, thank you so much. Okay, we are going to move on now to Simon Wick, who is from Norway. Simon, would you go ahead and unmute yourself and share your video and share your screen if you could, and walk us through your demo?
Oh yes. Let's see. It says you cannot start your video because the host has stopped it. Looks like.
Oh, have I?
See, but I can share my screen. Let's see. Share. And then let's see. Try to oh,
There we go. The video problem should be fixed.
all right. Let me try to let's see. Video. All right. Yes, there you go.
Welcome, Simon.
Let's see. Then go to here. All right. So unfortunately, I didn't get to implement uh, anything like end to end. So it's going to be a bit fragmented, and I don't really have like a good API demo to do. But I'm going to just take you through everything I have in the code here. So a lot of the ideas that Abdul said in the beginning, like those were ideas that I also kind of thought of, and yeah, everything is just great in that sense with the user manager and each user having its own timeline and like followers being like if I post something, then they get it in their timeline. But yeah, let's just so I chose TypeScript, and you said that there be dragons, and there were some dragons, and but
Experimental for a reason.
yes, so but it was a nice challenge. So so I took I used the multi Golem TS multi repository as a base, and let's see. Yeah, Noise 64 has been very helpful the entire like from start to finish of the hackathon. And
Dude.
so the project setup has commands for building and updating RPC stubs and generating component. So I could generate 3 components. First, I started out with the post component and just thought of the very basic. I tried to keep it as basic as I possibly could to try to implement something end to end. So just who owns this post, and what's the content of the post, when was it posted, and maybe some likes. Um, and I tried to figure out like how do I create a post, because I do have a post component, but the worker that holds the post, how do I like instantiate a new instance of a post? So that was kind of tricky. Um, so yeah, and then so yeah, just defined the interface for this, and then the user. So username and who is this user following, and also if you wanted to like have a query of who is following me, then yeah, having this uh, like yeah, who am I followed by on the user itself could be one. So you don't have to like query every single user that exists out there. And this was also a nice way to do worker-to-worker communication, because now I had to, from one worker, like myself, I want to follow someone. Okay, then I add the person to my following list, and then I gotta go out and check, like I need to get the other user, and then add myself in the list of yeah, his followers. And there was some it wasn't quite possible to do direct worker to worker on the same component. So what Noise told me was I needed some kind of a middleman. So I created this user proxy as this. So you can take a look at that. And it has an add follower, which just takes the followee, like the user being followed, and then it just forwards the following. So yeah, and so that's how one way I implemented this. Let's see, user. Yeah, implemented this worker-to-worker communication. Yeah, like It's not a whole lot more than that. A lot of the time was spent trying to fight a bit issues and stuff, and we did actually find some undocumented stuff. So, yeah, that's
All right. Well,
good.
thank you so much for that. It
Hmm.
was great to see you walk through your thinking on how to architect something that's scalable in number of users and whatnot using the primitives on Golem. And you did make a good stab at this and have some of the basics sketched out. So congratulations on that. Thank you so much for this
Thank you.
solution. Okay, we are going to move on now to Abdul Fattah, who is from Germany and who chose to do his implementation in TypeScript. Abdul, if you would just share your screen and turn on your camera and turn on your mic. Oh, sorry. Need to promote you to panelist first. That's going to help. There we go.
Okay, thank you. Can you hear me?
Yes, we can hear you now. Thank you.
Okay, thank you so much for the opportunity, and I'm really excited to be part of this hackathon. And this was my first encounter with WebAssembly and other languages. I'm basically a Java guy. I do everything in Java, and I also have some passion for Scala and functional programming. But when I heard about this new technology, so it solves many problems. So that's why I was very excited about learning this, and I'm going to do this in future as well. So let me share my screen. Sorry, yeah, can you see my screen?
Not yet. Some sort of difficulty with that.
Oh, I need to rejoin the call because this is the first time I'm using Zoom on my computer.
No worries. I will go ahead and promote you to panelist as
Sorry.
soon as I see you again.
Yeah.
All right. So he's going to have to exit Zoom and restart because that's the way things work on a Mac, apparently. And after he rejoins, I'll promote him to panelist and we will go ahead and take a look at his solution. Welcome back.
Yeah, thank you.
Yeah, that's more like it. Now we can see your screen. All right, go ahead. Take it away.
Yeah. So I unfortunately don't have the working demo. I mean, I do have some functionality working, but I don't have any demo that I can show you on the UI. I only have this console that can give you somehow an idea of what I have implemented. So I also have used the same TypeScript project, which I found on GitHub on Noise64's account. So that helped me a lot in worker communication. So if you can see here, I will go through the code as well, but so this is what I have currently. So if we invoke this function follow on the network component, so I created three components. The network component manages the worker-to-worker communication. So we have a user component and a network component. So when a user follows someone on this network, they go through this network component. So this helps in the worker communication. So as you can see here, user one is following user two, and then we have some logs here. this one. So if you connect to one of the workers, user workers, they show the log message, which is a proof that the message is successfully passed to the corresponding actor, worker, sorry. So this is what I have to show. Unfortunately, I don't have any UI. So
No worries.
yeah, so pretty much same architecture, user component and tweet component and network component. So this is a bit interesting, I would say. It implements this follow and unfollow APIs. And so the thing is that every user is responsible for its own state, for its followers list, for its following list, and the other pieces of information like username and bio, etc. So we are just calling the unfollow on the corresponding worker, and if we can go in the user worker, here we receive that follow, and it just adds in the followers list.
I like the fact that down there, the code that you have to basically unfollow in one worker, or rather scroll down to that infallible transaction that you're using.
Yeah, in the network component.
Yeah. That's an interesting use of Golem because ordinarily in distributed context, you can't say, okay, I want to talk to this service over here and unfollow this follower. And then I want to go talk to this one over here and do this and do that in an atomic way. It just doesn't work ordinarily. But when you do that on Golem, of course, it does work and you can rely on that. You can do sort of multiple updates across different systems and you can treat those multiple updates as being part of a transaction. And you're taking advantage of that here and maybe elsewhere. I think that's interesting.
Yeah, exactly. Yeah. Basically, this is one of the exciting features of Golem, I think. So we can transactionally call other services, and Golem basically guarantees that it will happen in a very guaranteed fashion.
That's right. It's exactly one semantics there for worker-to-worker communication. All right. Anything else to show us?
I think that's it. This is pretty much same architecture. I don't want to go into details.
Fantastic. Thank you so much for doing that demo. And I'll ask you the same questions I asked earlier, which is what was your favorite part of developing on Golem during the hackathon?
Yeah, so favorite part I would say is the worker-to-worker communication and not being worried about communication. Like, for example, if we develop this in some other technology like Spring, we have to create a lot of components and a lot of moving parts. So this feels like working in a single code base, just create components, and it's a frictionless experience.
That's really interesting. Thank you for saying that. We're trying to make the RPC sort of stub gem part easier, of course, and we will. But yeah, I think you make a good point that trying to do this using Spring or other traditional web framework, there's just a lot of moving pieces and a lot of stuff to get wrong and a lot of serialization and stuff that you have to see and leaks into your implementation. And here, all that stuff is just hidden from you and you're working with APIs.
Yeah, and one more thing, I think the database part, there is no database involved, even though we are working with maps, lists.
Yeah.
Yeah, so it scales very well, horizontal scaling. Yeah, that's a very interesting part.
All right, fantastic. And if you were to focus the efforts of our open source contributors on one thing, what would that be to simplify it or make it better?
Okay, one thing I had difficulty with was the rig language.
Yes.
Yeah, so I spent quite a lot of time on configuring the API gateway, and that's the reason I couldn't have the API, although I had the user interface in TypeScript, but I didn't have the API in the end, so I couldn't wire them up. So yeah.
Okay. That's good feedback. Thank you for saying that. That's great. All right. Thank you so much, Abdul. We're going to move on to our next competitor. All right. So let's go ahead and let Glenn Lewis go next. Glenn, are you here?
I'm here.
Hey, welcome.
Thank you. So let's see.
Excited to see what you came up with, Glenn. Why don't you go ahead and show us?
Okay, great. So let's see here. Desktop share. All right. So can you see my screen?
Yes, we can.
Okay, great. So I've been very interested in WebAssembly, and as a result of that, I've been very interested in the Moonbit programming language. And so when I heard about Golem and its durability and basically in-memory database, that was very interesting to me. And so I wanted to combine all these things. So I chose to use Moonbit. Like, as you said, it's not supported, but I wanted to have that as a learning experience here. So I went that route, and it was actually was a very great experience. So for the high level architecture, I wanted to keep it very simple. I wanted to have a user manager component that's very lightweight. I wanted it to only keep track of a user's handle and a globally unique ID that doesn't change. So even if down the road they change their handle to another available handle, the system would still know that that's the same person because of this globally unique ID. And years ago, I would have chosen a UUID, but in the last, like 4 years ago, I learned about XIDs, which have this amazing property that they're intrinsically time-stamped and also strongly typed. You can make them strongly typed. So I kind of focused my design on having user XIDs and also tweet XIDs to uniquely identify each thing, and thereby be able to sort them by time and such like that. So so I kind of started out looking at how I would design the endpoint. So in the README, I kind of put, okay, I need to register for a new account, get info about another user. I chose for the post to users to be HMAC protected endpoint, so that a client could, send a first request without any user being present yet. But then, which involves a client ID and client secret. But then for all subsequent calls, I wanted it to be JOT protected. So I wanted to return a JOT and then be able to call all the other, like follow, unfollow, get another user. Let's see, post a tweet, get a tweet, list them chronologically. So I designed basically out this API first. So let me see if I can show you what might be interesting. So let's see, here is okay, so here's the user manager. So the user manager only keeps just very simple things. So it keeps a map of all users mapped by their XID to their handle, and then it can go in the other direction. So it's basically 2 maps that it keeps up to date. And then I scoped out endpoints for and I wanted to point out that I wanted a singleton for the user manager that keeps all users. So it's kind of like the one resource, keeps it all in memory, because Golem can do that. And then I wanted one-to-many. So for every new user, I want to fire up a second component, which is a user component. So every user will have their own worker user worker. So the one user manager will talk to many user components, and then the user workers can also do many to many. So when you do like aggregated a list of all tweets from all your followers, then those workers would ask all of their followers, give me your tweets, and then they would consolidate them and then return the answer back to the front. So it's kind of like I forget what the name is, but it kind of distributes this workload and then consolidates, aggregates it, and returns it back. So I thought that might be a nice design. So these set of endpoints right here get forwarded to the many user workers. And then these ones that don't have forwarded in front are handled locally. So let's see, environment variables. So this is JOT handling. Here's registering a new user. At one point, I was kind of logging everything, and then I decided had some challenges at one point with things working, so I removed the logging. So those are commented out. But here's an update profile picture, so you can send a base 64 encoded JPEG, and it will store it with the profile. And then let's take a look at the user. So here's the user component. So it can follow another user, get a list of following. So it is also lightweight. It has a map of, so it does two things. So a user component knows everyone it follows, and then it also knows all of its tweets. So the tweets are stored. Let's see. Post tweet. There. So here are all tweets by this user. So they're kept in a map. And then again, they're tagged by their ID. Okay, so that's kind of a high level. Let me show you some of it in action. So here's like a typical XID. So it looks like that. And the nice thing is you can sort these XIDs and they'll be sorted chronologically and timestamp. So I don't want to waste time showing you that. But here is like creating a new user. So I'll run this command and I try to put them in bash scripts. Okay, so I just created a new user. I don't know, can I move this so that you can see that? Okay, great. So just create a new user and got back its XID. Then for what I really wanted to do was create a new worker for that user. I didn't get worker to worker going in Moonbit, had some challenges there, but here's the like, okay, that would delete. So here's creating a new worker for that user. So okay, so I just fired off a new user worker for that user, and then like here's how you would follow another user. So here's an example really quickly of following. So user one's following another user. So quick demo there. So let's see. What else? Did I miss anything? Is that good? What do you think?
Yeah, that's great. That's fantastic. So, are you just curious? You're able to post tweets and get back tweets?
Yes. So let's see. Let's go. So as I develop, I make a bunch of bash scripts that
That's
help
wonderful.
me to just quickly call it. So I'll just run this. Let's see. Oh, sorry. It's the okay. So this one, because it's in the user worker, I had to use the Golem CLI because I didn't get the worker to worker going. So I'll call this one and okay, so we just posted a tweet that Moonbit programming is fun. And there's its XID, which is strongly typed with the tweet underscore and then the ID.
Very nice.
So yes.
All right, fantastic. Thank you for doing that. So, Glenn, what would you say is your most favorite part of building this little back end on Golem?
So the thing that got me really excited about Golem is having everything in memory. because I just do not like relational databases.
Yeah. You're not alone there.
I do not like them. Yeah. You know, I've done a lot of NoSQL, a lot of blob storage, but having it all in memory, that's just amazing. So that's actually why I'm here, and
Wow.
I love that aspect of it.
That's great to hear. All right, thank you for that. And again, what should be our sort of next priority? If you could pick it, what would it be as far as improving the Golem experience?
So the rib really kind of tripped me up for hours.
Yeah.
And it is, I think it was mainly just because it was unfamiliar. And
Yeah.
and then in the UI, I got confused when it said like worker name or something like that. But then the examples it gave didn't look like a worker name. So but someone on the chat did help me. Thank you for everybody's help who helped me on the chat. I really appreciate it. But yeah, I think the rib kind of tripped me up the most.
Well, congratulations. You done a lot of stuff here, so it's great to see that.
Thank you.
All right. So now we're going to go on to Sita Ramaya, who is from the Netherlands and who chose to do his solution in a language that's not even experimental. We don't even have experimental support for Scala. So, but excited. Oh, wait. Looks like I need to make him a panelist again. 1 second. There we go. So yes, Sita chose to implement his solution in Scala, which was very brave indeed, because it's not even considered experimental support like the TypeScript and JavaScript support. We just don't even mention it anywhere. And so who knows what we're going to see out of this demo, but it was a very brave choice, or foolish, depending on your point of view, to choose Scala. Let's go ahead and see what you ended up doing, Sita.
Okay. Hello. Thanks for this opportunity, first of all. And it's because I like Scala a lot. From last 8 years, I like working in Scala. Anything comes from John Digos, I assume everything is related to Scala ZO and Scala Z. So that's my assumption is wrong. So, and that's the main reason actually I joined, but I'm not regretting now. Like I had a very nice 2 days hackathon. Okay, I thought of showing like what I was doing. Like everyone spoke about architecture and all. Everyone has almost same idea. There's no need to really talk about it. And the Scala we have as case classes. Those are we call it. Those case classes are perfectly suitable for these kind of things. And each and every user is a the user has a tweets, his own tweets or her own tweets, or in this say like one worker node, and this worker node or worker task, and of course like there is another user, and then that particular user has their own tweets and their own stuff or personal details, and how to communicate. Because I thought of really doing a worker to worker communication, but I couldn't. But I had a very nice fun over there. Like and at the end, like I did it a few of the things through. I call it as a API gateway, but maybe the terminology is wrong. But the overall that's what I was doing. And of course, I have so many challenges. But Afsal really helped me a lot. Like whenever I start with a rib or something, like he was helping me on that. And let me go to my code base, and it's yeah, it is so simple. Like I have simple case class here that has initially I thought of doing a really UUID, because I'm basically from Scala, not really Scala JS as well. I used UUID. UUID is not supported in Scala JS. I was like, okay, fine. At the end, like I'm using the names, but still, I left it this big end and all these things. And this guy is actually is following. Say, if he's following or she is following someone, and those initially it has to be IDs, UIDs or something like that. We need to keep it. but unfortunately it's not supporting. So that's the reason I put it in names there here. And initially the scalability point of view, we are not really following millions of users, so it is okay. Everything will be fit into the memory. And his own tweets, and then the tweets are also like a 200 characters. I limited it. I'll show you there, show you that. And this is what the API comes from here. And this is what the add user, add tweet, follow, unfollow, get tweets, and timeline. This is a fun part to me. I couldn't make it work, but the ugliest code in my life, I wrote it in Scala today. I tried whatever I tried, it didn't work out, but still, I'll show you. And rest of the code is okay, fine. And add
So
user,
you
add
couldn't
tweet.
find a way to make it work in the end, despite all your hacks?
No, nothing. Like I tried await. I mean, because like in Scala, everyone says don't use await. I understand why we shouldn't use await. Still, I thought, okay, fine, I'll use await. It didn't work out. So I tried thread.sleep. If someone Martin Odeski or someone hears that and they'll kill me, so don't use thread.sleep and all. So, but still, I use thread.sleep. It didn't work out. So at then, like when I tried, like when ugliest delay function, I wrote it to myself, like don't wait till the results come back. I'll show you that ugliest code. Of course, give me a minute. And this is what the Twitter API looks like. Same thing, same implementation. Add, okay, before this, I would like to show you API definition. The whatever the with file has, and the generated file is actually, we are implementing it in through Twitter API. And that for that one, we made an API definition. This is what API gateway I was talking about. And it has all the endpoints, like when say add user and add tweet for a particular user. And that user, this is awesome feature in, at least I like it. I don't know how about others. Like when all the request always goes to particular worker. Like if I mention it's like worker name here like this, it always goes to the same worker. Like I don't need to really worry about like rest of the things. So this thing I like it. Add tweet, and you can follow, you can unfollow, and that tweets mean this means get tweets, and this is a timeline. All these things are, we are mutating on the server side, so those are all posts, and we are only just getting, so these are gets. So that's it. And coming back to the code, like I'll show you the first implementation. At least what I did. I wrote a call script, like say, for example, I'm posting a tweet for a John, and all these John added all these tweets, and now, okay, I have all these tweets for Sita. And what is this? Like now you can get this tweets of Sita, for example. Oh shit. Sorry for language, but like it was working. Like this piece was working. Oh, sorry. This is the timeline. Sorry, this is not working. Sita get tweets. Yeah. This was all the Sita's tweets are getting back, and John's tweets are getting typo. John tweets are getting back. This is like a very trivial and nothing to really. It's nothing major here. Only thing which is very interesting is the timeline. Like rest of the things are very. In my opinion, it's very trivial. Nothing to worry about that. But if you see that one, yeah, this is what the timeline I was like trying to show. Just give me a second. Rest of the code is like a simple, like state management and state storing. That's it. And coming to timeline, this is what it's not working, but still, rest of the code is not, for me, it's not really challenging at all. This is the what a bit of challenging, but I couldn't make it. So I'm showing that piece which I am not which is not working. now what I did is like, I mean, every state has a user. That user has a following, like the following the users. That following user IDs, I'm fetching it, and supposed to be in a nice. If I can make it as in a future-based API, then it will be easy. But unfortunately, we don't have a future-based API, so I need to really block it, blocking fetch tweets. And I was thinking, like, I tried, I mean, you can see I was using all kind of libraries. I couldn't make it. And then first initially I put it a base URL from the environment variable and then use that and get all the tweets. It didn't work out. And yeah, I mean, fetch, I mean, I hard coded also one point of time, like when I thought it's maybe nothing, the printlns are not working, so I can't see. So I'm shooting in the dark. So I tried, I mean, hard coding, everything is I tried, it didn't work out. And then there's the ugliest part I was talking about is this one. I'm a bit like, to explain this one, I'm a bit ashamed, but like I don't have any option. So I'm just looping continuously until and unless I get back results, and I'm storing the results here. And fetch JSON, fetch JSON is a future-based API. And if I use await and it's not compiling at all, so what I did is like, okay, if you're not allowing me to do this one, I was just doing the same thing in a very silly way. That's it. Still, I'm not getting back the results. I was expecting it should work because it is working from outside, because I'm getting the tweets. This is what I hope you are seeing my. This is like base URL is nothing but the URL which we are talking about. User ID is user ID and tweets. This is the endpoint I'm calling. And if I'm
I hear
getting
you're running into a limitation of actually the JavaScript support, which is that you really want to be able to have APIs that return promises, or in Scala's world, it would be futures, and have that be treated by the host environment as lining up with a certain signature. And that's not happening, unfortunately. So that's why you're running into the difficulty here. And you're actually one step removed away from the root problem. There is a way around this. You can't actually work a way around it, but you have to use some sort of helper function that we expose in the Golem host environment. But anyway, I think I get the basic idea here. So anything else you'd like to show us?
That's it. Like, I mean, I thought of making a worker-to-worker node. I mean, I couldn't make it.
Yes, no worries. I think the fact that you tried to work around that by going through the front end HTTP API, and that's, by the way, the only way you could have made it work due to limitations in the sort of binding generator. I think the fact that you tried to do that shows A, for effort. You were going to use Scala and you were going to find a way to make it happen no matter what. And you almost succeeded in making that happen. So nice work.
Yeah. I thought if this last bit is a timeline is working, then I would be very happy. But I'm not disappointed, but unhappy. That's it.
We're getting close. So Scala will be on the experimental languages, I think, before the end of the year for sure. All right. Well, thank you so much. And if there's your favorite thing that you'd like to share about Golem with everyone here, that'd be great to hear.
Yeah, sure. Like, I mean, I already mentioned it about it. The workers always goes to the same worker. The request always goes. That's like, I like it. I don't need to really worry about, like, I mean, it's coming or that's not coming. I don't need to worry about it. Something like you don't need to really worry. I mean, if your language itself is an immutable language, you don't need to worry about the global immutable states and all those kind of silly things. I mean, which is, I call it as in Java, that's kind of a troubles I was facing a lot in the past, but not anymore. So I think, I'm not sure, maybe it's too early to say all these things right now. Maybe I'm seeing such kind of things are coming in that direction. I'm not sure about it, but I'm very curious about, like, I mean, without database, without anything, how persistence is managed underneath. I'm very curious because everything is in memory. Okay, I know about Redis and all these things, but how you are managing all these worker nodes data, or like
it's
the
pretty
persistence.
magical, isn't it? That's
Yeah,
a
exactly.
topic for another another presentation, probably, or workshop.
Yeah,
And
exactly. Like,
if there's something we can improve other than support for Scala, which I would assume would be your number one complaint,
exactly.
and we are focused on that, by the way, because I love Scala myself. We're going to
Yeah,
have
I
good
know.
Scala support at some point. So tell me, what's something else we could improve?
I mean the debug. I mean the debugging. Like, I mean, any programming, anything, technical stuff needs the first thing is a debug. Like, I mean, something goes wrong, I would like to debug first as a developer. So, and then the next thing is like I wanted documentation. Then I
Yes.
can run by myself. Like, of course, like, I mean, experts and all there help me. Of course, Upsell really helped me a lot, but yeah, I mean, if no need to really this much of effort is not needed if the debugging and then documentation is there.
Yeah. All right. Well, thank you so much, Sita,
Thank
for
you.
sharing your implementation. Great work. And now we're going to move over to Danielle Torelli, who is currently in Italy and chose Rust as his language of choice for his implementation. So I don't think this is Danielle's first hackathon. So I think you attended a previous hackathon, Danielle. And of course, you have been an open source contributor, particularly around our support for Scala. So please share your screen, turn on your video camera and your microphone, and show us what you've been cooking for the past 32 hours.
Yes, thank you. Hello, everyone. I will be sharing my screen for you. You should be able to see it. You see IntelliJ?
Yeah, we can see great. Thank you.
Thank you. So in order to represent the architecture, I tried to sketch it a little bit with some ASCII art here. So we have a router that is basically the central component that you would be calling, and that orchestrates all the actions and communicates with all the other components. And we have other components, one that handles the user data, one that handles the tweet of the user, and one that handles the timeline of the user. In all of this, this architecture, it would be sharded across workers. This means that there is a hashing function that will basically could be represented as a ring of 64 bits, where each user ID, and it's represented here, how it works. So the user ID gets mapped into a 64-bit hash that becomes a worker ID. And then from that worker ID, we get the specific worker that we want to invoke. Now, this hashing function, it's basically what determines this ID here. And the data of the same user, that means who this user is following and who is following him, and the tweet of the user and the timeline of that user will be handled by the same managers with the same ID. So when the user gets created, this shard start to be instantiated, and it's a lazy instantiation because if you just create a user, then just the user manager of that user will get instantiated, and then so on and so forth, thanks to Golem worker logic. So basically, the more you call the workers, the more they get instantiated. So for example, when that user will post a tweet, then the tweet manager of responsible of his user ID will contain that tweet. And yeah, there are some specific things that I would like to highlight on how this is working. So basically, when you want to follow somebody, the router calls the user manager that is responsible of that the user that you want to follow, and then it also calls the manager that is responsible of the user that is following, and basically makes the link. Then also I lazily build the timeline. So when those users are linked and a new tweet is posted, the timeline will be built for all the users that are following that user that posted the tweet. And then, of course, there is some other similar logic for unfollow. So when you follow somebody, it has also compensating actions in case something goes wrong. Then you want to post a tweet or query for user tweets and query timeline. Now, unfortunately, was I able to build some API on Golem, but I could show you how that works. I cannot show you the full functionalities because I think I messed that up, changing too many things at the last moment. And the last artifact that is building, I think it doesn't fully work. But I can show you for sure some function. And here for you, I have some clean workers ready. So we actually have only one worker, it is the router, and all the other components with 0 workers at the moment. So if we go, for example, to the router and to the workers, we see that there is a router singleton worker. Now, if we want to invoke, for example, registration, I want to register, this contains the username. So basically the interface for that is, I want to call a router action that in this case is register. And register takes a string, and basically that string is the username. So I can call that. It will be successful. And then you can see that it tried to gather what is the worker responsible for my user. And it went to create a user manager for my user. So you can see now that there is one user manager worker created that will basically handle my user. If I keep calling router with, for example, another username, it's very likely, since you have 64 bits, will get spawned into a different worker. And you can see, oops. Indeed, you can see that we have 2 active workers. Then, for example, let's suppose that we want to follow each other. So my user will have ID 0. John user will have ID 1. Oh, I can show you, for example, user profile. So my user ID is 0, my username, and I'm not following anyone. And then there is 1. So those are calling 2 different workers and getting the data. And then, for example, oops, if I want to follow, I want to follow user 1. This is where things start to not work. It says fail to follow, but if you go to actually see the profile, you will see that there is the following that has been added. And of course, if you see the profile, yeah, I think here is where I messed it up. So it's like followers. But anyway, I think more or less this gives you an idea on what I try to build. That is a shard with the user manager, tweet manager, and timeline manager for specific users. And
So you're saying every
yeah.
shard will handle a group of them.
Yes.
And how many shards total could possibly be created?
2 to the power 64. Now,
That's a
of
lot
course,
of shards.
yes, of course, you might want to use, instead of 64-bit function, you might use a short bit function so it will collide. And
It's
create
basically 1 worker
way less shard.
per user. 2 to the 64.
Yeah. Basically, yeah. But since we had to scale per user, then I wanted to build it large. Of course, you can always decrease the amount of bits that I use there in the hashing function, so that of course will fall into the same.
And one other quick question there: the shard, the worker names for the shard look nice, which means there must be some mapping process. I assume, like 1, 2, 3, 4. You have like 1, 2, 3, 4.
Yes.
How
Yes,
does that work?
there are IDs under the hood. So first off, the router is managing the worker IDs.
So when a new shard is created, that's
Yes.
when it's assigned some nice ID.
Yes.
Okay.
So basically, the worker has worker ID that is that 0, 1, so on and so forth. And then depending on of the component that you want to call, then it will call user manager 0, user manager 1, and so on and so forth. And then,
It's
of
okay.
course, that has
It's all clear now. Thank you. Thank you for
yes,
that.
no problem.
All right, fantastic. And you said you were not able to build an API, right?
No, I wasn't.
Okay. All right. Well, fantastic. This is quite ambitious. I looked and you have a lot of code here, so you've been very busy.
Yes,
Congratulations
yes,
on
thank you.
it. And what would you say is your favorite part of building this Twitter backend on Golem?
The simplicity. To be honest, it allows you to focus on the essential parts. And even though here you didn't see them fully working, it's everything linked. Actually, is everything implemented. So if I would have had more time to debug it, I'm sure it will work pretty good. So yeah, one thing that I would propose to focus on is for sure the debugging. Like it really help because I had to redeploy the worker, like even the project sometimes, like a lot of times. And yeah, but it was very nice, and for sure Golem allows you to really focus on what you have to do, and then all the boilerplate is basically on the side. The API, it's done for you. The guarantees are kept for you, and you just have to focus on the code. No databases, everything is in memory. Data structures is the paradise of the developer. So yeah, that was
Wow.
very nice
That's
experience.
great to hear. Thank you so much, Danielle. All right,
Thank you.
so what we are going to do is we are going to take like a 5 to 10 minute break. So I'm just going to pause this webinar here. And when we get back, then I will announce winners as well as provide a little bit of justification for why we're picking these folks as the winners. So see you all in 5 to 10 minutes. All right, we are back. So I know we took a little bit longer than we thought on deliberating, and that's because it was quite challenging, actually. And not surprisingly, no contestant actually implemented a full Twitter X backend clone. But that said, that's kind of ridiculous to expect that anyone would be able to do that in the span of 32 hours. So it turns out that no one was able to satisfy our requirements for a winning solution. However, some of you came closer than others. So even though none of you made it all the way, some of you are almost there. You're almost there to something that satisfies those minimum requirements. And in some ways, some of you went past that and did other things that we didn't even ask you to consider, which is fantastic. There's only 3 winners. So with 6 contestants, that means 3 of you will not be taking home a prize, other than perhaps a Golem t-shirt if you like. And we ended up deciding that the 3 contestants to not win are Simon Wick from Norway, who did his implementation in TypeScript, Abdullah from Canada, who did his implementation in Rust, and Abdul from Germany, who did his implementation in TypeScript. So we want to thank all 3 of you for contributing your solution to the hackathon. It was great to see your code and your approach, and the fact that many of you actually did a great job with some of the architectural components and thinking through that, as well as utilizing some of the features that Golem provides uniquely, I think, to building a distributed system like this. So thank you so much for that. The reason we ended up not going with your solution as one of the top 3 winners is primarily because you had a little bit of progress in one area, but there was still a number of areas where there was a lot of work left to do. So we want to thank you again, Simon and Abdullah and Abdul, for submitting your solutions. And please reach out to Christina if you would like your free Golem t-shirt. You earned it. You earned more than a free t-shirt, but that's all we have. Sorry. All right, so that brings us to our final 3 contestants, who are Sita, Danielle, and Glenn. And this was really tough, again, since no one actually gave us a solution that met all requirements. We had to analyze these solutions from a variety of different angles and then make some subjective calls, I think, on exactly which of them went further in the dimensions that matter most to building real production systems on top of Golem. So, Sita, we loved your tenacity in building with a language that we do not support for very good reasons. And we love the fact that you were able to, you did not have a full implementation, but you certainly saw the light at the end of the tunnel. And you ran into some difficulties which were caused by use of Scala, and which you may even have run into even if you had chosen to use TypeScript or JavaScript. But because you would have started with a different sort of example code base, you probably would have been able to overcome them if you had started from one of those languages. So ultimately, you hit a wall, and crossing that wall was not easy or probably even possible. And you had a lot of the pieces there in place. And the end was beyond that wall, but it was within a line of sight, I would say. You managed to successfully play around with API definitions, and you ended up learning enough rib to actually come up with some nice, clean API definitions, which is one of the things that we appreciated. You did not end up having worker-to-worker communication. And you did try that. You tried it through HTTP, but then you ran into some other problems that, again, that's that wall problem that we talked about earlier. Your architecture, however, was one of the things I really liked. And you're not the only one to adopt this architecture. But I did like it. for all those people who adopt it. And basically what it is it says every single user is going to have their own worker. And that worker is going to manage the user's tweets, the user's profile, and other sorts of information. Why is that a good architecture for Golem? Well, remember, Golem gives you horizontal scalability in the number of workers. And Golem lets you map API calls to specific workers when you're defining these as part of your API definition. And so that combination of features, which you utilized when you wrote rib to basically map some of this stuff to individual workers, is exactly what's necessary in order to make your solution horizontally scalable in the number of users on the Twitter clone. So that's great. That's fantastic. That's the correct way. All of the per user data are small data, right? The number of tweets that you or I could write is small data. Profile picture, bio, that type of thing, small data. So that is, I feel like it's the correct choice to have an architecture that is able to sort of store everything in memory using Golem and not have to worry about storing any of that tweet data in a database. And that brings us to Danielle's solution written in Rust. And Danielle, you did not have a full implementation, but you came fairly close. And that's great. We appreciate how close you came to being able to pull something off. You also, I think, are unique in the sense that of the solutions that were close to being complete and working, you pulled off worker-to-worker communication. And that's something that no one in our final set of 3 contenders managed to pull off. A lot of people came close, but no one actually implemented that worker-to-worker communication. And you succeeded there, which is something that we appreciated. You didn't end up having an API on top of any of this. So there was no API, there's no rib, there's no endpoints. It's basically all sort of in Golem. And while you can still test that, like using the console or the command line tool or whatever, ultimately there was no nice, clean, well-defined REST API, which counted against you. In addition, the architecture you ended up choosing does manage to shard tweets and also user-specific information. It does that by assigning users to particular shards. And then those shards manage all the data for everyone who maps to that shard. However, we felt that this architecture introduced a lot of complication. And by supporting this sort of sharded architecture, which is, by the way, very clever, and I have no doubt that there's lots of problems out there that could benefit from this sort of sharded architecture, ultimately, you didn't need that in order to solve this. In fact, your shard space is 64 bits, which is by far exceeds the number of users who would ever use a Twitter clone, even including bots. So you didn't even need that. And you end up with the same thing, which is basically sharding user data by worker. So adopting that architecture from the very beginning would have tremendously simplified your solution and also probably given you more time to work on the parts that you didn't finish. In addition, there's the issue of the routing table, which is currently a bottleneck. So even though you have the ability to partition all tweets into these different shards and address them and whatnot, you still do have a bottleneck. And with 300 million, 400 million plus users, that's most likely going to be a significant bottleneck. So your router there is probably not going to scale. And that definitely is an architectural decision that counts against you. And then finally, we have Glenn's solution. Glenn from the USA, who chose to write his solution in Moonbit, another programming language for which we have zero support. Glenn, you don't have a full implementation. And we looked at that, and we can see key pieces of like adding tweets and whatnot. There is, however, a fair amount of missing functionality, particularly around worker-to-worker communication, basically aggregating tweets from other users and pulling those in and merging them chronologically. However, we could see that you were on the right track. Right? Just a matter of time. If you had another maybe 8 hours or so, you would have gotten there. You had all the stubs lined up. You had comments describing what you should do. So it's clear that you would eventually end up overcoming those obstacles. We did like the fact that you sharded tweet data by user. So like some of the other best architectures that we ended up seeing over the course of this hackathon, you too decided to shard data by user. And we feel that's the correct choice because any user's own data is going to end up being relatively small. However, your architecture does have a bottleneck, and that bottleneck is basically the part where you are mapping the user ID into their stable long-term identifier. And that happens in the context of a singleton worker, and therefore it has to satisfy the load for as many users, concurrent users, as there are using the system. And store all of that data in memory. And if you're thinking about like 400 million users of the system, then you're going to run into scalability bottlenecks there. However, to your credit, no one else even thought about that problem. And in fact, it wasn't really required. You could have assumed that a user's ID is permanent for life and they can't change it. You could, in theory, have assumed that, but you sort of over-engineered the solution a bit in trying to make it realistic, and you ended up creating a scalability drawback. So basically, we're not going to hold that against you because other people, if they had considered that, maybe they would have ended up with a solution similar. So that's not going to hold against you. You got the basic idea correct here, which is that if you want to make this horizontally scalable in the number of users, then you have one worker to manage the state, the tweets of each user, and then problem solved. You got that part right. You made some progress towards worker to worker, but it looks like that ended up not being successful. You didn't get all the way there. So no credit for that. And then you did make some API definitions. So it looks like you were really getting how that worked, and you were able to successfully stand up new APIs with a minimum of assistance. You had a few questions, but more or less you just sort of went and ran with this. And maybe that's because you're already well acquainted with the drawbacks of early stage ecosystems like WASM. You've been doing Moonbit, so you know the WASM pains. You know it's not all the way there, and that you have to tolerate just a few catastrophes from time to time, or at the very least, lack of documentation, depending on what you're trying to do. So that basically summarizes our feedback. And basically, it was a tough call for us, but we have ended up narrowing it down. So what I would like to do is just ask all three of you to unmute yourselves and turn on your videos, and we will go ahead and announce winners. Welcome, Danielle, and then Sita, and then Glenn. All right, fantastic. I see all of you, so just go ahead and unmute yourselves there. Okay, fantastic. So coming in third place, we would all like to congratulate Sita for his solution written in Scala. So, yay, Sita.
Great job.
Thank you.
So, Sita, the reason why we're giving you third place is because at the end of the day, you weren't going to be able to make worker-to-worker communication work. And your implementation, it was like probably 60% of the way there, 70% of the way there, but there were still some pieces of that overall were missing. But that said, you chose the right architecture, and you actually surprised all of us in how much you did make work. We didn't, we were betting against you, right? Early on, he's choosing Scala. Okay, well, we don't know how that's going to turn off, but you actually managed to make a lot of that work. And so we really appreciate that. Congratulations, Sita, on winning
Thank you.
$750, plus, of course, a Golem t-shirt in your size delivered to wherever you happen to be. Amsterdam, I think, right? Amsterdam.
Yeah.
Yes, so we will send that shirt on, and congratulations again. Hope you had fun. Thank you so much for your feedback. And don't worry, Scala support for Golem will improve a lot, I think, by the end of the year. And we'll be in a different place entirely when we do the next hackathon. So I hope you come back in that next hackathon and you won't
for
have to
sure.
work around the language support quite as much as you did this time. Thank you very much, Sita.
Thanks a lot.
One more
Thanks a lot.
round of applause for
Thanks a lot.
Sita. All right, so coming up in place number 2, and this was a somewhat tough call, like all of these were, but at the end of the day, we decided we had to give this one to Glenn Lewis. So congratulations, Glenn, on winning second place prize,
Thank you.
which is $1,500 and your Golem t-shirt. And the reason why we ended up giving you second place prize is because there was just a few things missing that are kind of hard to get right. And in particular, that worker-to-worker communication. It's an essential aspect of that aggregation of tweets across different users. And that was missing due to lack of time. And we probably thought that because you were so focused on the authorization bit, which by the way is amazing. We love your authorization bit. And that's just the fact that you were thinking about that, as well as the user ID, stable user ID. You were thinking about these things and you started with them maybe, and you finished them and you did a great job with them. But putting the effort on those parts of the solution, I think, ended up taking away from the time that could have been spent on the worker-to-worker bits and the core functionality. So, but fundamentally, you did some amazing work here. And I'm so happy to see that Moonbit can be made to work on Golem. We obviously know about Moonbit, and it looks like it could be a fun language for writing on Golem, but you proved a lot of stuff out here. So any feedback you have on, can we make stuff better for Moonbit at some point would be appreciated. But
And I forgot to point out
congratulations.
the tiny size of the executables.
Oh, yeah.
The WASM files are tiny.
That's amazing. We've seen that before. Like the hello world is so many bytes, and not even Rust can come close to that. Like Rust is like, I don't know how it's like 100 kilobytes or something, but Moonbit is just so tiny, itty bitty. The hello world is just like a few bytes. It's astounding how tiny that is. I think Moonbit is a fantastic choice as it matures for building on Golem, just because it plays to the strengths. It's designed for WebAssembly, so it really does play to the strengths of the ecosystem. So thank you so much, Glenn. Congratulations again on coming in second place. That is well earned.
Thank you.
Congrats.
All right, which brings us to Danielle. No shock, Danielle, but because there's no other choices, you are the recipient of the first place prize. So congratulations for winning $3,000 and a Golem t-shirt. Although for $3,000, you can buy all the t-shirts you want, probably. So you don't even need that t-shirt. So congratulations, Danielle.
Thank you very much.
So the things we loved about your solution is, well, you obviously know what you're doing. You've been involved in Golem Hackathon, another Golem Hackathon in the past. So you bring your experience in Golem architecture with you, and you pushed yourself. This is the most ambitious project you've done on Golem before. And we can see just a lot of sort of thinking about how you utilize Golem's architecture to the max, and you were able to do sharding basically. And you would have to utilize that if you wanted to build something like a distributed relational database on Golem or something like that. You'd have to think about sharding, and you would shard by workers, and every worker would have a little bit of data. And you might even have to do that in some cases for like user management on a Twitter clone on Golem. So I'm not saying sharding is necessarily wrong, but we could see your distributed systems thinking, and it's great. You understand the core ideas of Golem, and that leads you to build architectures that take advantage of Golem's durable states, etc. So that's fantastic. You did end up sharding the tweets, and that counts in your favor. Basically, every worker, or rather, all the tweets for a single worker or for a single user are going to end up stored on a different worker in your solution. So you ended up getting that part right. Again, the thing that counted against you was the fact that there was a lot of complexity that didn't need to be there, because at the end of the day, you are basically creating one worker per user. And it's just simpler to, have one worker per user and there's no problem with having 300 million, 400 million workers because almost all of them are going to be inactive at any one point in time and so forth. So that would have been a much simpler architecture. And then you did have a sort of bottleneck in the sense of the router. Basically, everything ends up going through the router. And that means that it's not truly scalable to 300, 400 million. You're basically looking at how many concurrent users could be managed by a single in-process worker, together with how many inactive users could fit in the storage space allocated to that single worker. So there are ways to solve that, obviously. But I don't want to spoil that for those of you who want to try this own challenge problem on your own time. There's ways you could have worked around it. There's a way to design this on Golem that has sort of no bottlenecks and can easily, and none of you were too far away from it, right? Not that much complicated. You just need to be thinking in terms of, okay, if we do have a singleton worker, that worker better not be called very often. It certainly can't be called for every one of our 300 million users. And I think just a few people in desiring to solve the bigger problem, which is how do we make the tweets horizontally scalable? A lot of people weren't even thinking in terms of are these singleton workers really the best path to go down? But anyway, you did worker to worker, which is really, really hard. You did it. You sharded the tweets by user ultimately. So you ended up with, you didn't have the API definition, but we felt that that's relatively easy to add after the fact, right? You had the big picture pieces. You could have done an API definition, probably given half an hour or an hour, whatever it would have taken. And you were focusing on the most essential part of the problem. And if you're going to put a very interesting, complex, sort of meaty problem or meaty solution on Golem, then mastering worker to worker, as well as some of the architectural considerations, are key. And we saw that from you. We saw you were mastering worker to worker. You had a lot of, not all, but a lot of the architecture right. And we fully believe that you could have finished the implementation, given a couple more hours of work, and then an API definition on top of that would have been relatively straightforward. So you were very close at something that did everything, with the exception of the bottleneck, the scalability bottleneck, which we're not going to hold against anyone because everyone had some sort of bottleneck in one way or another. So congratulations, Danielle.
Thank you.
are the recipient of our first place prize, which is $3,000. So that's vacation, new laptop, who knows what, a little bit of mad money. Hope you have fun with that. Did you enjoy the hackathon?
Yes, it was very fun. And also using Rust. For me, I didn't have much choice to use it. So it's always fun and I always discover something new. So
Yeah,
thank you very much.
absolutely. All right, so at this point, I want to thank all of the Golem team members who helped out with the hackathon. I saw a lot of help from David and Afzal and some from Daniel and so forth. And just I really want to thank all of those Golem team members for working the weekend, so to speak, and helping to get everyone up and running with successful solutions. That was great. I also want to thank our marketing department and Christina for helping to organize this and promote this and get the word out. It's great to see such a strong showing and how many people ended up building Twitter clones on Golem. That's fantastic. And then I want to thank, most of all, our hackathon participants. You were given an impossible job, and all of you managed to make a lot of progress. And you probably leveled up many times your knowledge of Golem, maybe distributed systems, how durable computation factors into building highly scalable, highly reliable systems. And probably you're probably gonna maybe start dreaming about like how it is you use a platform like Golem to really rethink the way you build large scale distributed systems. It is an eye opener. Right? All of you built something without a database that can scale horizontally. Almost all of you built something that can scale horizontally in number of users, doesn't use a database, stores persistent tweets. Everything is sort of type safe using ordinary code. That's kind of mind blowing. And I hope it really does open up doors in your own personal development experiences. Now that Golem is out of beta and is suitable for production use, maybe bring it into your workplace, right? Build something real. And those of you who are watching, who've been watching from the outside at the whole hackathon process, I hope you too have been inspired by the types of applications you can build simply using a durable computing platform like Golem. Golem's ready for people to give it a try. So if you want to learn more, then definitely check out the homepage at golem.cloud. And our developer documentation center, which you heard from some of the contestants, is good enough to get stuff done. Even though we can improve and we will be improving, the documentation center has come a long way from our developer preview last year to what it is today. It's now ready, I think, to be put through its paces. And we'll take bug reports, we'll take fixes, we'll take suggestions for improving that. But you can actually go out there, you can read it, and you can build something, and you can put it all the way in production. So please, if this inspired you, go out there and build something and show it to us. And don't forget that we are planning a whole conference called Durable Computing World that is going to happen in a matter of months. It's going to happen fairly early next year, I think March of next year. And that's going to happen in Washington, D.C., and we will be having a big hackathon at that event. So if you want to get on this hacking, we're going to follow a similar structure, and you're going to be able to hack either there in Washington, D.C. in person, or you'll be able to join us remotely if you want to join the hackathon from anywhere in the world. They're a lot of fun, maybe a lot of work too, but also a lot of fun, and you get a chance to build something nice using shiny new technology like Golem, which is exciting. All right, thank you, everyone. I will